Hey guys, Mr. B here again, bringing another awesome math video. I've been going a bit wild here this morning, making all kinds of math videos for your watching pleasure, and we've been stuck on this topic of prime factorizations in my class, so that's why I'm sort of inspired here today to bring you a few math videos. And so one of the other uses that we've talked about, sort of what can we use a prime factorization for, and there's a lot of uses for them. And one of the things that we do in my class, GCF, LCM, and another very useful thing to do is reducing a square root or simplifying a square root. So if you have a square root, or any type of root, really, it could be a cube root or whatever. Square root, of course, most popular. So if you have a square root, and 108 is not a perfect square. If you take the square root of 108, let me just do it on my calculator here real quick. You get 10.3923, yada yada yada. And so in math, we're obsessed with having some things simplified. So one of the ways that I teach my students how to simplify this, and is really useful because you're already probably really familiar with how to do a prime factorization, is to use a prime factorization. So again, I'll write my primes out on the side over here so I can refer to them. And what we do is we start with the L method. So I take my number 108 and I divide it by the number, the smallest prime that divides it. So 108 divide by 2 gives me 54. 54 divide by 2 is 27. 27. Oh, not 22. 27. 27 divided by 3 is 9. And then 9 divided by 3 is 3. So there's my L. And so my square root of 108, I'll rewrite it over here. 108 is now equal to the square root of this prime factorization. So 2 times 2 times 3 times 3 times 3. So now what we want to do is we want to make groups of 2. And we want to have the exact same thing in each one of those groups. So what I mean by that, let me just change my color. Let's go to a nice blue. So what I mean by that is I want to have 2 of the same numbers in a group. So if you can see here, I want to have 2 and 2 and 3 and 3. So it doesn't matter that we got something left over. That's just going to happen, especially when it's every single time it's going to happen when it's not a perfect square. So there's my 2 identical groups. So what we can now do is we can rewrite this as so the square root of, it's not quite black, is it? The square root of, and inside this set of brackets is 2 times 2, so that's 2 squared, times, inside this set of brackets, 3 squared, times 3. So now we can use our little rule. So you might have seen this before. So if you have something like square root of a times b, well, that's the same thing as the square root of a times the square root of b. So we can use that in this little guy right here. So we have the square root of 2 squared times the square root of 3 squared times the square root of 9. So the reason why we want to do that is because, of course, when we have two numbers multiplied by itself, 2 times 2, 3 times 3, that gives us a perfect square. So the square root of 2 squared is 2 times the square root of 3 squared is 3. So that's 2 times 3 outside of, and root 3 is not a perfect square, so we got to leave it alone. So now we end up with 2 times 3, well, that's 6 root 3. And there it is. So 108, square root of 108 is equal to the same thing as 6 root 3. So some people might call this this is the entire radical, and this is the mixed radical. So that's a really great way of using it, of simplifying an entire radical to a mixed radical. Now, it's not the most efficient, but it will work every single time. Why don't we try one more? So let me erase this stuff. I'll keep my primes there. So let's see. Let me come up with a decent example here. So let's take, this is not really the great example, but it is what it is, 200. Alright, so let's start out. 200 divided by 2 is 100. 100 divided by 2 is 50. 50 divided by 2 is 25. 25 divided by 5 is 5. So there's my prime factorization, my L. So now I can rewrite 200 as square root of 2 times 2 times 2 times 5 times 2. And so again, I start making groups with the exact same number in each group. Let me get a different color this time, green. Alright, so here's my first group, 2 times 2. And here's my next group. So they don't have to necessarily be in a row, like these are separated. That's fine. We can rearrange the numbers of these however we want to. So that leaves me with 2 squared. So this is 2 squared times, and then I'll skip this 2. I'll leave that till end. And then 5 times 5 is 5 squared. And then times this extra 2 right here. So that leaves me with 2 squared times 5 squared times root 2. So using that method where we can take anything multiplied underneath and we can rewrite it such that it's individual square roots. So square root of 2 squared is 2 times square root of 5 squared is 5 times root 2. So we end up with 10 root 2. And there you go, guys. Another application of prime factorization. Really hope this helps you in your math courses, and I hope it helps my students, of course. And I'll see some of you guys in class. Take it easy, and I'll talk to you later. Thanks for watching.